same as we did for other inverses. The only difference is because our original function has logs or exponentials, we'll have to use logs or exponentials to solve. But as far as the process goes, it's the same. Switch the x and y, solve for the new y, replace the y with f inverse of x. So it's that same process that we did on inverses before. And then use Desmos to check your answer. I would strongly encourage you to do that. How to check inverses in Desmos. So I made you a little chart here. What you're doing, we haven't done this middle thing right here in a minute, and I'll show you that in a second. Is the graph symmetric about y equals x? So if you get something like this, and you can tell, yes, it's symmetric about y equals x, the functions are inverses. Sometimes you'll be able to tell, no, definitely not symmetric here. So the functions are not inverses. Some of these might look really complicated, and you can't decide, right? So, like this graph, I think probably looks symmetric, but it also is a very complicated looking graph, and I don't feel like super confident about it. So, let me show you this one other thing in Desmos. Sometimes kids don't like this because it confuses them, but like, if I have y equals x, and like, let's just say I'm going to do a simple one, y equals log base 3 of x, and the inverse of that is 3 to the x power there. So this one's not super complicated right here. So I think you could probably look at that and tell, oh yeah, those look like inverses. That's what I'd go with first. Yes, these are inverses. But let's say you're not sure. One option is to check points like we've been doing some. You can check points. Let me show you something else here. When you're finding an inverse algebraically, what's the first thing that you do? So when you're trying to find an inverse with the equation, what's the first thing that you do? It was on that list on the slide before. What's the number one step there? Switch the x and y's. Okay, watch this. If I take this y and turn it to an x, and I take this x and turn it to a y, it turns into the same equation as our answer, right, as our inverse. So if you can't tell from the graph, you could just switch the x and y's in the original and see which one it matches, because that's that first step that's done there. So that's another way you can sort of check if you're unsure right there. We'll probably primarily just rely on looking at it to see if it's symmetric, but sometimes it's hard to tell. All right, so let's find the inverse of this. All right, first of all, that g of x is really just a y right there. We're treating that like it is the y. So the first thing we want to do is switch the x and the y. So that will look like this. X equals 3 to the y power plus 1. Okay, so if we've got x equals 3 to the y power plus 1, we want to solve that for our new y. So we are trying to get this y right here by itself. Heston, what do you think we should do first? We already did the switch to x and y, minus that 1. So we got x minus 1. We just have to write x minus 1. We're not going to get a number answer for this. Equals 3 to the y power. Okay, so we're trying to get that y right there by itself. Nate, now we've got to get rid of that 3. How are we going to get rid of that 3? What? I can't hear you there. Very good. We're going to log. What does the base on that log need to be? Good. So we are going to log with a base of 3 here. That will get rid of this. Now this is important. We are log base 3ing the whole other side, so we're going to put parentheses around whatever is there. Log base 3 of everything on that side, x minus 1. Put those parentheses around it because you're logging everything that's on that side. If you don't put that in parentheses, it'll have the minus 1 like out to the end, and it'll be a different answer. So I'm getting log base 3 of x minus 1 equals my y. We're, in general, going to write the final answer with g inverse of x notation instead of the y, and we'll have log base 3 of x minus 1. And if we want to check that, using Desmos here, we could just type in the original, g of x equals 3 to the x plus 1, and I'm just going to do y equals log base 3 of x minus 1. Alright, so does this look symmetric about that line y equals x? Could we fold that in half? Looks good, so that lets you know that you've probably done it right. You know, let me show you something. Like, let's say we forgot those parentheses and we had x minus 1. It's not that easy to catch. You got to be careful because that looks about right if I forget those parentheses. But you could, like, right here I could change this to an x, I could change this to a y. Oh, sorry, that's not an exponent. Like that. Are those the same? If you switch it, they're not. So that's not the right answer. But if I put parentheses around this, then they do match up there for that. There. So the graph is not foolproof, but it helps for those. Okay, questions? All right, you try these next two on your own. Okay, try these next two on your own. Find the inverse for each one of these functions. On the first one here, thank you, x equals 4 to the y minus 2. On this one, you're going to add 2 first. That will give you x plus 2 equals 4 to the y power. And then, thank you, Zoe. Then, Hector, how do I get rid of that 4 right there? How do I move it to the other side? Like, am I adding, subtracting, multiplying, dividing, logging, exponents? Huh? Nope. It is the base of an exponent. How do we get? We got a log with the base 4, which will cancel here. We're logging base 4 of this whole side, of everything that's over here. So we want parentheses around it. So we get log base 4 of x plus 2 equals y. And the y is by itself. They didn't use function notation on this one, so I wouldn't like change it to f inverse of x because they didn't use function notation in the beginning. Just leave it like this. Okay? Questions on that one? All right. 3 is very similar but a little different, and there's little things that make a big difference here, so check to make sure you got this right. X equals 3 to the y minus 5. So, Sophia, on this one, what have we got to do first? I can't add the 5. It's in the exponent. I can't get to it yet because it's like trapped up here. I got to get rid of the 3 first. I got to log base 3 first. So you guys see the difference? Okay, so what that's going to do, that'll get rid of the 3. I'll have log base 3 of x. You can put parentheses around the x or not. It doesn't matter. But what you need to know is like the next steps are not inside of those parentheses. And then I just have y minus 5 right here. Because that's all that's left on that side. Now what would I do, Sophia? Add that 5. And when you add the 5, it does not go on the inside of the log. okay, because you're doing this after you have logged this stuff. So that's one reason I kind of like putting the parentheses there, to be very clear that that 5 is not included in the parentheses. You also can write it this way. It is still correct, log base 3 of x plus 5. If you don't have parentheses, it is assumed that the only thing that goes with the log is what is right behind it. So like if I don't have parentheses, it is assumed that the parentheses would just be around that x. Okay, it's why it's really important here to have those parentheses. This one has to be written log base 4 of parentheses x plus 2. If you don't have those parentheses, it is wrong for that.
10th graders with the last name S through Z, please report to the Media Center.
Okay, questions? All right, moving on, let's do some that have logs involved. Okay, so same thing, switch x and y's. So x equals log base 5 of y plus 2. And like I was just saying, if they don't put parentheses, if there are no parentheses with your log, it is assumed that the only thing that goes with that log is just whatever's right behind the log. Sometimes they'll put the parentheses there, sometimes they don't. But if they don't have parentheses, it is only the thing that is right behind the log that is included in that log. So, in this case, Fernando, what would I need to do first on this problem? Very good. We're going to subtract that 2 here. So I've got x minus 2 equals log base 5 of y. And then Richard, I'm trying to get that y by itself. I've got to get rid of the log base 5. How do I do that? What's the inverse of a log? Exponential. So I'm going to take the base of the log and I got to make it the base for an exponent. So I do 5 to the power here, just cancels. I got to do 5 to the power here. The whole thing right there is in the exponent. So I got 5 to the x minus 2 is going to equal y. And that whole x minus 2 is in the exponent. Questions here? All right, for example 5, we got x equals 3 natural log of y. So on this one, Carson, what am I going to need to do first? I can't subtract it because it's not added to my other stuff there. What's happening between that 3 and that log right there? It's being multiplied together, right? If those two things are right next to each other, they're being multiplied. So I divide. So I'm going to divide by 3 here and divide by 3 here. And I'm just going to have to leave that x divided by 3 equals natural log of y. I think natural log is throwing us off a little bit. It was one of the ones we had more trouble with. If you don't like it, a natural log could just be changed to a log with a base of e. It's the same. So, Maze, if I'm trying to get rid of that log with a base of e, what do I have to do? Good. So I'll do e to the power, e to the power. I'm raising this to the whole thing right here. So I'm going to get e to the x divided by 3, that whole fraction is in my exponent, equals y. Okay, and you should, if you start off with a log, you should end up with an exponential, right? If you start off with a log, you should not get another log in your answer. Logs are not inverses of logs. Okay, here. All right. Try these next 4 on your own. All right. So, what's the base on this log for number 6? It doesn't have 1, so it is a 10. So, we got x equals log. I'm going to write the 10 just to be very clear about what's happening there. Y plus 2. You're going to have to do 10 to the power first thing. So we got 10 to the x power. Oh, sorry. Equals y plus 2. Here. So base is 10. Switch your x's and y's. To get rid of that log, that's the first thing you have to do here. You're going to do 10 to the power. 10 to the x equals y plus 2. Last step is just to subtract that 2. Whenever you subtract the 2, you're not taking it away from the 10. You can't take it away from the exponent. It is just 10 to the x minus 2. There. Okay? Example 7. You're going to switch your x and your y's. You got an x equals 3 to the y minus 5. You're drinking another one? Your heart is going to explode. Oh my gracious. You already had the giant one.
I got one more in the truck, and I got another one, the big ones this morning, and then I have like another.
Healthy choices. All right.
It's not okay.
It's like everybody.
But this is like the same day. I only had 3 yesterday.
Yeah, only 3.
Your heart is
I'm gonna go and say something now.
And then 2 7 right there.
You sure you're okay?
I'm going to say something.
All right. More life lessons to work on. Don't have anything to do with it. All right, so let's see. Y'all are not going to make it when you get old and are actually tired. Oh, my. Okay. All right, we're solving for a new y. That was a poor choice. Poor choice. Yeah.
Like I had like 3 yesterday and I crashed.
This,
And I woke up at 7. And I slept right.
are you seeing that this is a little like the Charger situation? String of bad decisions causing more bad decisions.
No, I'm studying.
Hey, Hector has not yet actually passed on the crime. All right. We're going to add the 5 right here. We get x plus 5 equals 3 to the y.
With the last name C through G, so please report to the media center.
Heston's just going to look wired in this picture. He's like... All right. Okay. What do we got to do to get rid of that 3? Log base 3. And so, log base 3 of x plus 5 equals y. Those things are expensive, too. Yeah, like all energy drinks are expensive.
2 for 4 yeah, gas station.
Yeah.
Oh, like it's have 2 exact calories. That has 160. That's the total.
All straight from sugar. Yeah, who knows what else? I mean, you just try to read those ingredients.
Hey, you tell me what citric acid is. It's like a type of
You can't either. It's a bunch of crazy stuff nobody can predict. Only 27% of your added sugar for the day. It's vitamins. It's good for you. Uh-huh. Yeah. Alright, put his drink back. I'll pass it around. You gotta get that niacinamide peroxide in the morning. That's gotta get you going. Yeah. I don't know. Alright, let's look at 8. What do we gotta do first on 8 after we switch X's and Y's? Log. What's the base? So we're log base 10. Do we really have to write the 10? We could just write log X. That would be fine. Okay. Add that 3. It's important to note that X plus 3 is not in parentheses here. Like if you were going to include parentheses, it's just around the X because that 3 got added last for that. Okay. Last one here, I think. This is the last one, right? Okay. All right. Abby, what should we do first on, well, after we switch X's and Y's? So X equals 2 log base 3 of Y minus 1. After we switch X's and Y's, what should we do first on this one? It's not going to be a base of 2. Because the base of like that log is our 3, but we can't get to it yet because the 2's in the way. Any ideas? Nate? We're going to divide it off because it's just multiplied right there. So you got to divide. That was throwing some of you guys off on one of those quiz questions as well. You were like logging something that should be divided first. So if it's just a number out front, you're going to divide it. So we got X over 2 equals log base 3 of Y minus 1. All right. Then, now, we're going to use the base, right? So now we're going to do 3 to the power, 3 to the power. So we got 3 to the X over 2. You don't have to have parentheses there, but I just want to be very clear that whole thing's in the exponent there. Equals Y minus 1. And then, Hunter, what's our last thing we would do on that one? What? Got to get rid of that minus 1. What are we going to do? We're going to add that 1. Good. So, you can't add it to the 3. You just have to write it like this. 3 to the X over 2 plus 1 out here on the end. Okay? And like especially, that's about as complicated as it should get for you on these, but especially on those that are a little bit tougher, it's a good idea to do f of x, or y, I guess it was, y equals 2 log base 3 of x minus 1, and then graph your answer, y equals 3 to the x over 2 plus 1. Make sure they look symmetric. They do. So we've got that. Okay, questions?